Okay, let's do another example on multiplication of complex numbers. Now the first one is two complex numbers multiplied to each other, 6 minus I with 4 plus 2I. Now this goes back to your multiplication of some polynomials, if you remember. You can keep one of them fixed and distribute the other. So I'm going to keep 4 plus 2I fixed and distribute 6 minus I to this one. So I can write this as 6. Now remember, we're keeping 4 plus 2I fixed. 4 plus 2I, then minus I, again multiplied to the expression 4 plus 2I. Now we will distribute 6 inside 4 plus 2I. 6 times 4 is 24 plus 12I. And now distribute negative I to 4 plus 2I. Negative, I can write this as negative 4I. And a negative 1 with 2 is negative 2. I with an I is I squared. Now we can gather the two like terms. Here notice these are two like terms and replace the I square here. So what do we see? We have 24 plus 12I minus 4I is 8I minus 2. Now remember, I square is going to be replaced by minus 1. We get 24 plus 8I plus 2. We're almost there, guys. So 24 plus 2 is 26 plus 8I. So we're writing this two multiplication of complex numbers as one complex number, 26 plus 8I. Now let's look at one more example, which is 2 minus I squared. Okay, now if you remember the formula for a plus b squared, you can do that, but I would recommend opening up and writing it as 2 minus I times 2 minus I. Now we're going to keep this part fixed and distribute 2 minus I to this one. So we're going to have is 2 times 2 minus I multiplied to 2 minus I. Now distribute the 2 inside. 4 minus 2I. Now distribute minus I inside this expression 2 minus I. Minus 2I plus I squared. Minus with the minus makes a 1. Now gather the like terms. You get 4 minus 4I. Now remember, this I squared is minus 1. So plus minus 1. What do we get? 4 minus 4I minus 1. The final answer is 3 minus 4I. So this is how we learn about multiplication of complex numbers. So let's look at one more concept called the complex conjugate of a complex number. Now, if you have a complex number, say z equals a plus bi, the complex conjugate of this number z is given by a minus bi. Let's do some examples. Now 4i. Before I do 4i, let me look at 3 plus I. Very similar, it's a, so remember this is your a plus bi. So b here is 1. So a, when you look at the complex conjugate, the one part which has no I next to it remains the same. So this is 3. And b here is 1. So the complex conjugate is minus I. So the complex conjugate of 3 plus I is 3 minus I. Now for 4i. The complex conjugate is, now remember, this is the same thing as writing as 0 plus 4i. So the constant part is 0. So the complex conjugate, so here the complex conjugate will be 0. Now plus 4. Remember, the conjugate will have a negative term to the positive 4, which is minus 4i. So similarly, for 3 plus I, which we've already done, is going to be 3 minus I. So we have found, looking at the conjugate, complex numbers, its conjugate. Let's go and do some more operations on it. It says, multiply the following complex number by its conjugate. Now we know this complex number is 4i. Its conjugate from top is negative 4i. Now this is easy to do because you're going to multiply the constants and then you're going to do the I with an I. So you get negative 16, and now I when multiplied to I can think as of the exponent properties, it's I squared. So it is now going to be minus 16 minus 1. The final answer is 16. Let's look at the other example. 3 plus I. Now we know the complex conjugate is what? 3 minus I. Now, in order to do that, we'll have to again do the whole multiplication. Now I'm going to keep 3 minus I fixed and distribute 3 plus I there. So it will be 3 times 3 minus I plus I times 3 minus I. Now we do the normal algebra here. We get 9 minus 3i plus 3i minus I squared. Remember, plus with the minus, minus I with an I squared. Now gather the like terms. Notice negative 3i and 3i, positive 3i. They're opposites in signs but equal in value. I'm basically meaning the value in terms of the numbers here. So they cancel out. What are we left with? 9 minus, now remember your I square, because we are complex numbers, I square is minus 1. So I replace this by minus 1. So what do we get? 9 plus 1, 10. Now notice, very important thing. When you're multiplying a complex number by its conjugate, you always get a real number. So 4i with its complex conjugate gives me a real number. Similarly, 3 plus I and 3 minus I, I'm getting it a real number. Okay, now we're going to look at the last operation on a complex number. We're going to look at quotient of complex numbers and then write it in the standard form. Now the steps are, whenever you get a problem, the first thing is you look at what is in the denominator of the complex number given to you. So our denominator here is 4i. So what we do is we look at the whole expression, we multiply the denominator and the numerator by the conjugate of the number present in the denominator. So what is the conjugate of 4i? We just found was minus 4i. So we multiply and divide by negative of the 4i. Now, after that, it's simple algebra. So 2 plus I times minus 4i. I'm going to write minus 4i, 2 plus I in the numerator, and then multiply in the denominator 4i with negative 4i. Now, in the numerator, we're going to just basically distribute minus 4i. We get minus 8i. Minus 4 with the 1 is a minus 4i squared. Denominator, we already just did it previously. It's going to be negative 16i squared. Now replace the I squares by minus 1. What do we get? Negative 8i minus 4. We're going to replace this by minus 1, guys. Keep that in mind. Denominator negative 16, I squared becomes minus 1. Okay, so in the numerator we get negative 8i plus 4. Denominator we get 16. Now remember to write it in the standard form. The standard form is, remember the standard form is of a complex number is a plus bi. So basically you have to separate the a's, the constant real part and the imaginary part of a complex number. So looking back over there, we can write this as minus 8i over 16 plus 4 over 16. You can do some simple algebra here. This is negative I over 2 plus 1 over 4. And then we can just, write it in the proper standard form as 1/4 minus I over 2. Okay. Also, we can write this if you want to be more careful, as you want to see the b here. It's the same thing as writing 1/4 minus half times I. Basically, they are all the same, guys. So one more example, guys, of the quotient of two complex numbers. So let's look at this example. 1 minus I over 3 plus I. Remember, the step is to multiply this expression by the conjugate of the denominator. Now we have already seen the conjugate of the denominator is 3 minus I. So we're going to multiply 3 minus I over 3 minus I. Now go ahead and just do multiplication in the numerator and in the denominator. As I've previously done, 3 plus I times 3 minus I, and we got the answer to be a 10. So I'm going to save some time and write 10, because this part has already been done previously in the same video here only. So let's talk on the numerator. So in the numerator, I'm going to keep 3 minus I fixed and distribute 1 plus I here. So I'm going to write this as 1, 3 minus I plus I times 3 minus I. So what are we getting? 3 minus I plus 3I minus I squared over 10. Add the like terms, minus I and 3I here. So we get 3 plus 2I. Now remember, we're going to replace this I squared, this one, guys, by minus 1 over 10. So adding 3 minus 1, we get what? 2 plus 2I over 10. Now to write it in the standard form, I can write this as 2 over 10 plus 2I over 10. Little simple algebra. This is the same thing as saying 1, 5 plus 1, 5I. Okay, so you see the answer, 1 minus I over 3 plus I. Oh, I made a mistake, guys. So this should be 1 plus I. So I'm just going to make this 1 plus I. Okay. Yeah, a little mistake, so just make it, okay. I didn't realize it was 1 minus I. So I'm just going to keep it as 1 plus I. And here is our answer. No, small mistakes, guys. That's okay. So here we are. and hopefully it will help you do your problems. So thank you and see you later.